I've been getting some questions about the circuits lab, so I'm going to try and walk you guys through this lab real quickly. Um, so I've already gone to the PhET site and downloaded them. Hopefully, since you guys have been doing this all semester, you kind of know how to do that part. So here's kind of what the simulator looks like. You want to make sure that you hit voltmeter and ammeter so you can have these, access to these. And then basically it wants you to make a series circuit. Okay, so I'm going to make a circuit that looks just like the one in this picture right here. And so I'm going to take my resistor, I'm going to put it in the bottom. I'm going to put my battery towards the top. I'm going to put a switch over here. And then I'm going to put an ammeter at the top. And then I'm going to go ahead and I'm going to connect my wires. Now they have wires at each corner, but you can just as well do this. This will work. You just basically need to make a circle. And then it's not going to work immediately because your switch is open, so you're going to have to close your switch. Now that the blue dots are flowing, you can see what you've got. I can put my voltmeter here on the battery, so I have a 9-volt battery. And so my potential difference is going to be 9 volts, and my current is 0.9 amps. If I want to find the resistance of that particular resistor, I can just do R equals V over I, so I'll do 9 divided by 0.9. Let me get my calculator. So I'm going to get 10. And I'm just going to write ohm, but you could always copy and paste this little symbol in. Okay. Then that's going to be trial 1. Then they want you to add a second battery. So what I can do is I can say I want to split this junction. I'm going to get rid of this here. And I'm going to add another battery. I'm going to put it back. I'm going to put this here and this here. Okay, so now I have 2 batteries. So my I have 18 volts and my current is 1.8. And so then my resistance is going to be 18 divided by 1.8. And it's still going to be 10 ohms because, you know, my resistor hasn't changed, right? It's exactly the same. Okay. And then you can do the same thing with a third battery. Okay. Then you can, this is saying exactly what I just told you. The resistance of each is going to be exactly the same. And then we're going to create a series circuit. So we're going to take out these extra batteries. So I'm just going to say remove. Okay. And then I'm going to have my original setup. Okay. My battery voltage hasn't changed, but I'll put it here anyway. So it's going to be 9. And my current is 0.9. Okay, so my resistance is R equals V over I, so 9 divided by 0.9 is still 10. And then the total resistance of this circuit is just going to be, you know, R1 plus R2 plus R3, but we only have R1 right now. So it's just going to be 10 ohms. I'm just doing this here so you can see it all in one line. Okay, so then what we're going to do is we're going to make a second. Okay, so we're going to make a second circuit, or like we're going to put another resistor in this circuit. So I'm going to just take this resistor right here, and I'll take a wire and put it right here. And now we've got 2 resistors, right? My current, or my voltage, is still 9 volts, right? That hasn't changed. My amps are 0.45, they've gone down. Okay, so my resistance, I can do 9 divided by 0.45. I'm going to get 20. Okay. Okay, so now I want to do R total. And this time R total is going to be R1 plus R2, right? So we already know that these resistors are exactly the same, right? Because we haven't changed the resistance. We haven't, told it to do anything else. So we've basically got 10 plus 10, which equals 20. So you want your answer here and your answer here to be exactly the same. If they're not, then you're doing something incorrectly. Okay, and I'm going to let you do the third one. Okay, I'm going to let you answer the questions. I'm just kind of setting up the lab for you. Then let's try a parallel circuit. So the first one is we're just going to have one resistor, just like we did with the series circuit. Okay, so we're going to have 9 volts, and our current is 0.9. So the resistance of this resistor is 9 divided by 0.9, which is still 10 ohms. That, that math hasn't changed since the last time. And then for this one, you want to do R over Req equals 1 over R1. Okay, so 1 over Req equals 1 divided by, now our R1 is just 10, right, because we only have 1, which is 1 divided by 10. So we have 1 over Req equals 0.1. And then we have Req equals 1 divided by 0.1, which is Req equals 10. Again, you want these two to be exactly the same. Okay, then we're going to build a parallel circuit in here. I'm going to try and make a circuit. This is the one I made earlier today when I was trying to talk a student through the lab. So I'm just going to try and recreate this circuit. And it may help you. It kind of helps me if I kind of draw the circuit on paper first. So then I kind of have an idea of what I'm trying to make. Sometimes that helps me kind of give me an idea of exactly what I'm after. Okay. Okay, so that's connected. Now I want to do another one. Okay. So this is going to be my, okay, so this is my 2 circuit one. Okay, or my two resistor one. My battery is still 9 volts, but I'll, check it here just so you guys believe me. So it's 9 volts. My total current is 1.8 amps. Okay, so if we do 9 divided by 1.8, this is going to give you your total equivalent resistance for the circuit. Okay, so this is a parallel circuit. So I'm going to do 9 divided by 1.8, and I'm going to get 5. Okay. Now, when I want to do my 1 over Req, let me move this out of the way because I see this little Dropbox thing. I want to make sure you guys can see this. So I do my 1 over Req, I'm going to do 1 over R1 plus 1 over R2. Now both of these resistors, we know that they're, you know, they're 10 ohms because we haven't changed that. But if you wanted to figure it out, you could do, you know, 9 divided by 0.9 and you would get 10, and then 9 divided by 0.9 here and you would get 10. So you know that each one is 10. So we'll have like 0.1 plus 0.1. So 1 over REQ equals 0.2. We'll have REQ equals 1 divided by 0.2, which should give us 5, but I'll check it just in case. So that gives you 5. So now they're exactly the same. Okay, you can see that this one is the same as this one. If you and then when you go to do the third one, you'll just add, you know, one more right here. In this one, I have switches, but you don't have to have a switch if you don't want to. I just kind of put them in there because I think the lab asked for them, but it doesn't really change anything. So that's how you would do your, you know, your parallel circuit with 3. And you can still see that each one of these is 0.9. So you would have your 9-volt battery. So if you wanted to find, you know, your total, you would do 9 divided by 2.7. And then if you wanted to find your individual resistor, it would be 9 divided by 0.9, 9 divided by 0.9, 9 divided by 0.9. So they're all 10 ohm resistors. Okay, so that's what you would do for the third one. You would do 1 over 10, 1 over 10, 1 over 10. Okay, and that's how you do this lab.